David Smith here with another flipped classroom math video. A few tips before we get started. Remember, you can always pause the video if you need to catch up with your notes. You can also speed up or slow down the playback if that helps. Finally, you can turn on the captions so you can see my words going by at the bottom of your screen. Today's topic, dividing radicals. We just did multiplying, now we're doing dividing. A quick review. Here was our rule for radical expressions that have divisions or quotients. This is your fraction bar. If you have root A over root B, that's the same as just the root over, or A over B inside the root. So we'll probably take advantage of this rule at one point or another. Now, there's this convention in mathematics. We don't like radicals in the denominator. There's nothing wrong with that. That's a completely valid mathematical expression. However, in mathematics, we have conventions in various places, and this is one of them. What we want to do is remove radicals in the denominator. So this is a very simplified expression, but it's got this root in the bottom of the fraction, or in the denominator. So we need to remove it. We're going to do that for 4 of these problems, and then we'll take a look at some slightly more complicated problems. So there's just a trick that we use for this. You just have to remember it. We multiply this expression by 1. So you can multiply things by 1 all day long and nothing changes. You just times it by 1. But we're going to use a special form of 1. Root 3 over root 3. Okay? That's 1. So we're not going to change this at all by multiplying it by this. We'll get another expression that's exactly equivalent to this. But here's what happens. On the top, we have 6 root 3. That's just 6 times root 3. On the bottom, root 3 times root 3 is just 3. That's simple, okay? I find students sometimes struggle with this. I think if you practice it and think hard enough about it, it shouldn't be too difficult. Okay, so try that one. Okay, let's see how you did. Since there's a root 7 on the bottom, I'm going to multiply it by this version of 1. Root 7 over root 7. That's still 1, but it's a slightly different form of 1 than that one. What we get now is 35 times root 7 over 7. Now, are we all the way done? No. 35 over 7 reduces down. 35 over 7 is 5, so this ends up being 5 root 7. So these problems will often have extra steps after you've gotten rid of the root on the bottom. Then you need to look at the whole thing and see if there are some reductions that are possible. Okay, give this one a try. 3 over root 3. Very similar to that one. Okay, let's see how you did. We're going to multiply by root 3 over root 3. Again, that's just 1. Different version, but it's just 1. This is going to give us 3 root 3 over 3. Are we done? No. I can reduce 3 over 3 to 1, so this ends up being just root 3. So again, another step after we've removed the root from the denominator. Let's take a look at that one. Pause the video, see if you can do it. Okay, let's see how you did. Again, I'm going to multiply by root 3 over root 3. That's pretty straightforward. Now let's see what we got. We got 9 root 3 over 3. So 9 over 3 is just 3. So this one ends up being 3 root 3. Okay? So again, an extra step after we got rid of the root sign on the bottom. Okay, let's do a slightly different, definitely more complicated version of these problems. I think some of these problems are the most complicated in this chapter. You may wish to watch all the way through and then rewind and take your notes. Sometimes that helps build understanding quicker. Okay, so root signs in the bottom. We need to get rid of them. That's our convention. So we're going to multiply by some version of 1. But it's not so simple anymore because I have 2 terms down here. So how am I going to get rid of that root? The secret here is I'm going to use that same pattern, that difference of squares pattern, to exploit this and get rid of the root signs. So what I'm going to do is I'm going to multiply it by 3 plus root 2. And 3 plus root 2 on the top. Now, that looks pretty complicated, but that's still 1. It's the same thing on top of itself. So this reduces down to 1. So I'm not changing my expression, even though it really looks like I am. Okay? So here's why I picked that. This thing minus the other times this thing plus that same other is just going to give us this thing squared minus that thing squared. So that's going to give us 9 minus, what's root 2 squared? Is 2. Presto, notice, no more roots. And it was pretty easy, just one step to that. Now I have to do my distributive property on the top, my rainbow. So I'm going to do 5 times 3, that's 15. And 5 times root 2 is just plus 5 root 2. So I'm not done yet. I need to keep simplifying. 15 plus 5 root 2 over 7. Now in this case we are done, but we might not be, and we'll do a later problem where we'll have to actually reduce a little more. If we can divide 7 into 15 and 7 into 5, we could reduce that down. In this case, we can't. So this brings up a concept that I like to encourage people to understand. Sometimes in mathematics you get what I call ugly answers. This one might not be so satisfying. We didn't get just one little term, or we didn't get like something like 5. We got 15 plus 5 times the root of 2 over 7. That's an ugly answer. It's even hard to kind of know what that number really is if we put it into decimal form. You could pull out your calculator and do that, but as you remember, we're not doing that in this chapter. We're leaving the roots under the roots. Okay, so that's that problem. If you want to try, this one is fairly similar. Pause the video and see how far you get. Okay, let's do it. We're going to multiply by 1, a weird version of 1. It's going to be this thing minus that thing. 7 minus root 5. Notice how on this problem I multiplied it by the plus because this was the minus. On this one, since the plus is here, I'm going to put the minus there. And I'm going to do the same thing on top. So again, this is just 1. It's a very weird and wacky version of 1, but it's 1. So now I can exploit my difference of squares pattern, and it's just going to be the first thing squared minus the second thing squared. So that's going to be 49 minus root 5 squared is 5. So there's the bottom. Presto, no more roots. Now I'm going to do my rainbow. 9 times 7 is 63. And then 9 times negative root 5 is negative 9 times root 5. Now let's finish her up. 63 minus 9 root 5 over, what's 49 minus 5? 44. Now take a look again. Are there any common factors that we can cancel here? 63, 9, and 44. And unfortunately, there aren't. So this is even another ugly answer. Maybe even more ugly than that because the numbers are bigger. Okay, one last example. This one is going to end up with perhaps a little bit more of a satisfying result. 6 over 8 minus root 6. So what we're going to do is multiply by a weird and wacky version of 1. It's just going to be this thing, since that's a minus, it's going to be this thing plus that thing. So it's going to be 8 plus root 6 over 8 plus root 6. So just 1, just a weird version of it. So now let's do our math. It's going to be this thing squared minus that thing squared. So 8 squared is 64, fraction bar. Root 6 squared is just 6. So I have 64 minus 6 on the bottom. Do my distributive property, rainbow. 6 times 8 rhymes, that's 48. And then 6 times root 6 is just 6 root 6. Now I can combine my bottom. 48 plus 6 root 6 all over 64 minus 6 is 58. So, like I said before, sometimes you need to take a look at this and see if you can reduce it down. I'm going to go step by step because I think that's the way most students approach this. They're all even. So let's just divide them all by 2. So this is going to be 24 plus 3 root 6 over 58 divided by 2 It's going to be 27. No, 29. Sorry, 29. Okay, so 24 plus 3 root 6 over 29. Can we reduce that any further? There's a nice clue that you can't. 29 is prime. So there's no other factors of 29 besides 1, and so that's going to stop us from reducing these two down. So again, an ugly answer, but we got a new step in this problem. Our first result from doing all of our multiplication did have some common factors, which in this case was just 2. So we just cut everything in half. Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below. And if you'd like to help me grow my YouTube channel, please click subscribe.